All right, we'll start by doing a few practice problems from homework. And most of y'all probably have not attempted this, so it's good for us to practice it and help out Chelsea and Shannon.
No, I know this.
Yeah, I'm sure you did, yeah.
You know you take notes.
Yeah.
Okay, I had an excuse last night. I didn't get off work till late.
Right. Just a whole lot of blah,
It's
blah,
not an
blah,
excuse if
blah,
you don't want to do it anyway.
blah. Yeah. All right, so this is an example from homework. I think it's number 1. You've got y equals 3x squared plus 12, y equals 4x minus 4, make sure I'm copying this right, 4x plus 4. And then we are on the window from -3 to 3. Okay? And they ask you to find the area that is enclosed by these boundaries. Okay? We'll take this one the long way. We kind of need a good practice problem with this. What are some things I need to know? What are some things I need to know before I can just jump right in and set this problem up?
What's on top and what's on bottom and where do they intersect?
Which function is on top, which function is on bottom, and does that condition ever change? Do they ever intersect and then flip-flop places or something like that? So step number 1 is going to be to find the intersection places. Intersection points. All right, how do we find intersection points? I think Michael was saying we set them equal to each other, is what we do. That's what I heard in the mumble. All right, so 3x squared plus 12 is equal to 4x plus 4. The idea here is this, just again to give you a crude sketch of things that could happen. You could have function on top, function on bottom, start, stop. So we'd be looking at that kind of area, maybe. We could also have something like this, where part of the time one function is on top and part of the time another function is on top, in which case we would need to know where they met so that we could flip-flop them. And this could happen any number of times, so they could trade places a lot of times. We just have to know where they hit so that we can put the appropriate function on top and on bottom. And let me erase my crude sketches here. Remember that our general formula is going to be antiderivative from a to b of the top function minus the bottom function, d whatever, dx, dt, whatever, okay? So I'll try not to erase that for the sake of this. We may need to do more than one of these if the top and bottom change places. So that's what we're trying to figure out first is, does the top always stay on top or does the top switch places with the bottom at some point?
You don't have to.
Do it?
Never mind.
No, it does not have to.
I don't think it does.
If you know anything about graph theory or if you feel pretty good about your graphing technique, this is an upward parabola, this is a line with a positive slope. So either the line is always going to be below the parabola, or there's going to be a point where the line cuts through the parabola. So we're either, or we could hit a tangent spot where it looks like it wants to cross over, but it doesn't, okay? We'll figure it out when we do this. I'm going to bring all this over, set it equal to 0. Let's see. 3x squared minus 4x plus 8 equals 0. Go with AC on this one. 3 times 8 is 24. Factors of 24 that add up to -4. Okay, if they're going to multiply to give you positive 24 but add up to -4, that means they both have to be negative.
I don't think anything.
And there isn't a big enough negative number to give you a -4 in the middle, so it's not going to factor. If we try quadratic, the thing about the quadratic, some of y'all just kind of dive right into it. It's not wise to do that. Check this part first. This is what we call the discriminant back in Algebra 2, okay? This is the part, if you know your formula for the quadratic, this is the part that's under the radical,
Which.
okay?
is screwed.
If that's positive, then we do get two answers. If it's negative, then we're done and we move on, okay? So for this problem, let's check. The b squared is gonna be negative 4 squared minus 4 times a, you know what? I'm not even gonna do the math because 16 is certainly not gonna outweigh that. So whatever this is, it's gonna be negative,
Which means.
which means we have i's in our answer, which means these two functions don't touch each other, okay? So thanks for trying, and it was good practice. We needed to know where they cross and where they didn't. So they never intersect. That means that whichever function is on top is always on top, and whichever function is on the bottom is always on the bottom.
I can tell you which one on top.
Based on what we know graphs do, you should know that, or you can pick a test point.
Zero.
Pick like 0, yeah. Stick in 0, you get 12, stick in 0, you get 4. This one's bigger, so that's the function that's always on top. So my integral is gonna be a pretty straightforward one problem setup, going from negative 3 to 3 of top minus bottom. Top function is going to be the 3x squared plus 12 minus the bottom function, which is 4x plus 4. And honestly, when I get to this phase right here, I don't even worry about what the original problem was. Okay, yes, we're doing an area problem. That's just a straight up antiderivative. Okay, so context to me at this point is gone. As long as my answer is positive, then I haven't screwed up. Okay, if I get a negative area, then I have really messed up something somewhere. I would clean it up a hair before taking an derivative. 3x squared minus 4x plus 8 dx. All right, antiderivative, x cubed minus 2x squared plus 8x on the interval from negative 3 to 3. Stick in positive 3, we get 27 minus 18 plus 24. Stick in negative 3, we get negative 27. We get negative 18, and we get negative 24.
Positives.
These two will actually cancel each other out because that's really a positive 18. The rest of the stuff doesn't cancel. We get, these are basically gonna be the same number. 27 and 24 is 51,
So 100.
so 102. That total area between those two graphs in that zone is 102 units. Graphically speaking, this is crude, but graphically speaking, I think you got the line doing this, you got the parabola doing
It's a little bit higher.
well, not to scale, parabola doing this, and then you're going from negative 3 to 3. This is a really, really big scale, by the way. So you're calculating all this area in here, which is 102 units. Ta-da. How'd that feel? Pretty
It's
good?
a pretty unsteep slope for 4x.
I changed my scale. I'm counting these by 1, and I'm counting these by like a lot because you gotta get way up there. It's a really steep graph. Yeah, that's it.
Mr. doesn't know how to draw a 4x line.
I know exactly what it looks like. You know what, I need the whole board for this next one. Y'all good? Matt, good, Mavericks, okay. This next one illustrates an interesting point that you probably have, I'm not gonna say forgotten, but probably not paid attention to in a very long time. All right, for this example, let's make it kind of easy. Number 1 is 4 minus x squared, and number 2 is x squared minus 4,
Well, that's kind of
okay? And that's all they tell you.
which one's on top? It's obvious that they're going to intersect,
Why?
because there's literally one's at 4, one's at -4, and they're both just a normal parabola going from that,
Good.
but they're up.
So again, because I have a great deal of understanding about graph theory, what the things are supposed to look like, yeah, they're gonna meet, and they're probably gonna meet in a decently nice set of coordinates as well. We'll go through the math on how to find that, but you're right.
These would be negative.
Graphically speaking, I guess we could do a crude sketch. You have first parabola, they're both parabolas, up here at +4, that goes down,
Wow.
okay,
Plug in a nice 2 there.
like that, right, and it will hit at 2. Second parabola has a y-intercept of -4, and when you go up, I believe it also hits at 2. Okay, so crude sketch, this is what we've got. So we're looking at the zone in here, okay?
Nice mirror.
Algebraically, keep that in mind, do keep that in mind. Algebraically speaking, if we were to figure out where these two intersected, we would say 4 minus x squared is equal to x squared minus 4, and then practice our algebra. I'd bring the x squared over, I'd bring the 4 over, divide, and I get x equals plus or minus 2. Don't forget when you take a root like that, square root, you need the plus minus, which confirms what our picture told us. Notice what they did not tell you in the very beginning. They didn't give you a starting point and stopping point, they didn't give you a zone. They expected you to be able to find that zone. So again, they probably on this one would have used words like find the area bounded by. In that case, if they don't give you a zone, they expect you to be able to figure out where the starting point and stopping point are,
Or should be the bound part.
which would be the bounded part of it. So integral setup, here we go. We're gonna go from -2 to 2. Which function is on top? Our down parabola,
Yeah.
all right, so 4 minus x squared minus x squared minus 4 dx, and again from here, it's sort of like robotic mode. Okay, we've done this enough.
Yeah.
I'd clean it up once, -2 to 2. We're gonna have 8 minus 2x squared dx. Antiderivative is going to be 8x minus 2/3 x cubed on the interval from -2 to 2. Okay, let's see here, sticking 2, we get 16 minus 2, 4, 8, 16/3.
Yep. And then
Again, -2, we get -16, and we get positive 18, or 16/3, excuse me.
which one? Here's the negative thing.
All right, so the 16 actually becomes positive twice, the 16/3 becomes negative twice, so we're gonna get 32 minus, 32/3.
Which,
Common denominator is 3, that is 96/3, so 64/3. So our final answer is 64/3. Good. And I know we zipped through the arithmetic there, but that's something y'all should be decently good at.
beep, boop.
Beep boop, yeah, robotic mode. That's not what was exciting about this one. There's something I want to point out that happens not a good deal, but it happens enough to talk about. Look at the picture, the crude picture, which is not half bad.
Michael's living here.
Not here.
Yeah, and I know he was actually referring to this upright mirror, the old school
Old school, yes.
Cinderella kind of
Yeah.
mirrors.
Mirror on the wall.
But there is a
That's no-
kind of mirroring here. You'll notice that the top half of this
It's the same as
is the same as the bottom half, so we could have saved ourselves a bit of work
And just
by
do-
only finding the area of the top half and then doubling it, or, here's the other trick, this zone is what we call even. Do you know what the difference is between even and odd? When we're talking about a graph, what it means to be an even graph or an odd graph.
Even though it is is when you plug in negative y, it's the same thing.
Other way,
If you plug in negative x, it's the same thing.
as positive x. Graphically speaking, it is symmetric with respect to the y-axis. So it's like your Rorschach test. You fold it and you get you know, like that. Odd,
Where's my mask?
okay,
Mm,
Makes it, where's my face?
okay.
You get it? Rorschach.
Oh, Rorschach, yes, from The Watchmen, yes, gotcha.
Where's my face?
It took me a while to get what you were, it's The Watchmen, it's a comic book,
It's a great.
yeah. Odd functions, you've thrown me off track now.
I'm sorry,
That's all right.
you said Rorschach and I have to.
Yeah. Odd functions look like that, where you have this rotational symmetry. Okay, let's talk about area. In this one, we happen to be going from -2 to 2. In any even function, if I'm going from, say, -a to a, you do have symmetric area. So if you just want to find half the area and double it, that's a neat trick to use. If you're doing the same thing on an odd function, okay,
Exact.
all right, so if I'm doing the exact same thing with an odd function, what should my area be?
0.
0, because all the positive area should cancel out with all the negative area.
But if we're doing,
Now, area between curves, yes, it's a different story, right? But just to throw this idea out here, so I'm gonna work this one a second way, just throwing the idea out there in case you ever wanna consider it, because it is worth mentioning. What we could have done was, instead of going from -2 to 2, we could have gone from 0 to 2, and then doubled that area, okay? The reason we would do that,
if we were going for the,
yeah, the areas are symmetric, but there's something really nice about the setup that makes it advantageous. We're gonna go from 0 to 2 of that function,
the first part cancels.
and then I'm gonna double it, okay? Taking half the area, and then we're gonna double it, which will give us the area that we're looking for. Okay, fast forward down here. We've already done the antiderivative, and we got 8x minus 2/3 x cubed. I'm just pulling this straight from here. And I'm going from 0 to 2. Alright, here is one of the big reasons that I like doing this. If it's easy to see, and if it's easy to get into, here's why I like doing it. When I stick in 2, I'm gonna get 16 minus 16/3.
And then for 0, you get 0.
You're going to get 0, and that's why it is sometimes really nice to do it, because anytime I get to use the number 0, I love it. 0 works beautifully in just about any function you could pick, all right? You know, it's over 0, but yeah. Polynomials with 0 are fantastic. Exponentials with 0 are fantastic. Anything to the 0 power is 1. Trig functions are fantastic. Your answer is either 0, 1, or undefined, depending on what kind of trig function it is. So using the number 0 and my second favorite number of 1, if I can ever use that, doesn't really work well in these kind of problems, but something to consider. I'm not even going to bother working this out. You end up with 2 times 32/3, which does give you your 64/3. So something to consider. I've got a few practice problems today that you can do it a long way like that. This will shave off a few seconds, and those few seconds might be worth it in the end. Okay?
And really, we did the same thing over here, we just. 'cause
It
was
just
the
made it
same
one
thing.
step.
It just made this one little plug-in easier to manage. And sometimes that might be all the difference in, you know, getting 2 extra points on the test, so who knows? Who knows? Okay. Let's clear the slate. There goes that one. Let's do 1 or 2 more, and then I'm gonna jump in with today's exciting stuff.
How exciting is it?
So exciting. All right, ladies and gentlemen, let's see how you do setting this one up on your own. here is your zone. I would like the area enclosed in that zone. Okay, pretty straightforward. So let's spitball here. What do you think would be a pretty good approach to start?
Could give the Y intercept, or, I don't know.
There's y-intercept, okay.
Y.
Of which one?
What do you know, which ones?
There are 3 equations up there.
Which is them all?
All of them? All right, so you get all their y-intercepts. All right,
I want that help, it sounds nice.
we can do that. I think at this level, an algebra 1 kid can do that, so I think we can do it. I think,
You hope.
I hope. Can I just set up an integral and run with it? Is there anything fancy to it?
No,
Okay, integral, here we go.
except, first you need to find out where they intercept.
Oh, crap.
How they look.
Fine.
If
What,
they say
how
they
you,
can
how
touch
they
other
look at 3
people or
lines.
something.
Well, I guess with 3 lines, it's, I'm guessing they want, because there's no thing, they just want the bounded areas, so you just have to figure out on the graphical stand where they are. and how-
Do you want, you said graph, do you want to graph it?
Kind of,
Okay.
that would make it look a lot
I-
nicer.
This is your problem, I'll graph it. Alright, bear with me. We don't have good graph paper today.
You not bring your board,
I didn't feel like lugging it down here today. We weren't doing a lot of graph.
just leave it down here, so keep
I
it.
use it a lot over there too, so I can't, I need another one. Oh, that's ugly.
Just ask the district, they'll get you.
Yeah, I need to hit up the district again for more money.
They understand calculus,
They do.
raising the world.
Alright, that's a little bit better. Cockeye. X plus y equals 4.
X was Y.
What does that look like?
It's good old, 4, and then that's a -1, so.
Okay, so that one is going, let's put 4 right here, and it's got a -1 slope, so it's gonna hit 4 down here. Let's call it that line right there.
That one right there. It's called
Okay.
that line right
So that'll be x plus y equals 4. Got it. X minus y equals 0.
X
It's
is
just-
Y.
So y equals x, if we solve, okay, that's
there. So it's just a straight line to the origin.
through the origin, well, they're all
Not
straight.
Well, it is a straight line.
That's redundant. Slope of 1. And then,
So being redundant was not fun.
if it wasn't fun, it's not helpful.
And,
All
oh,
right.
it's supposed to be helpful. And, okay, and then the 3x, okay, so it's gonna be good at the same 4, but with a 3, with a -3 slope.
-3 slope, okay,
It's
so
gonna be
that
a
one's gonna
little
look
tiny area.
kinda like this.
Yeah, a little tiny
Okay, so the area in question is here. That's the only zone that is actually bounded. Everything else has an open side to it, so it's not bounded.
area. Okay, now how to find that?
Good, so how to find that? Well,
Can't we just tilt it?
interesting, we need to tilt it.
Well, because we have a nice x equals y, and you can just like make that the x-axis pretty much, so you could think of it, the x minus y equals 0, and the x plus y equals 4 are pretty much intersecting, so that could easily be, so you can look
Like
at
the
it.
x-axis, you're talking about like kind of rotate it so this is the origin?
Yeah,
Rotate it down? Works for me.
I don't see why
What
not.
would that make this one then?
Math. I can figure it out.
All right, let me tell you how you'd have to do it. Figure out what kind of rotation we're talking about, so how many degrees, all right?
45.
and then do the exact same thing to
3x.
that.
So negative 3x.
And what that would do to the slope if we rotated it, because I think the y-intercept would,
So
might be, no, it wouldn't be the same. The whole thing would actually, if we swung it down, it would actually drop just a hair, the y-intercept would not be there.
True.
But I mean, I like where you're going with this. Okay, think AP test. Is that what you would do on the AP test?
Takes a long time, so probably not.
All right, I can think of two viable solutions. One of them is calculus related, which is what we'll probably do first, and one of them is geometry, okay? Let's go, by the way, the geometry is more in line with what you were trying to do with this picture, all right? Let's go calculus. Huh? It is a triangle, so
Just find out the length.
base and height, yeah, we could go with 1/2 base times height. That's the geometry approach to it. Do you wanna do that first, or do the calculus first?
That counts.
Calculus? All right, calculus. So here's the calculus approach. By the way, the geometry approach only works in this picture, not with
Curves.
curves or other kinds of triangles. Okay, there's something very special about this particular triangle that lets the
That's the right.
geometry. It is indeed a right triangle, because this slope is -1, that slope is +1.
That's the only reason.
You do end up with a right angle, which means if you cock your head a little bit, base height,
Yeah.
okay, so it's easier to do that way. Trick is to figure out what is the base and what is the height, which isn't that bad. But let's go calculus first. So the calculus says we're supposed to go from starting point to stopping point, top function minus bottom function. Okay, so let's decide on a starting point and a stopping point. Where does this area begin accruing and where does it stop?
0 to wherever x and x minus y and x.
0 to here?
Yeah, 0 to the.
All right,
Yeah.
0 to whatever that is.
It's called p.
Well, it's pretty easy to figure out. This is the equation,
You just find out the.
just figure out where these two meet each other.
Okay, so they said equals.
Right, and by the way, like this is pretty easy. You can do substitution or elimination. If you add the two functions together, the y's cancel, so you get 2x equals 4, so x equals 2. All right, so this is the point 2, 2. This is the point 0, 4.
Distance. I'm guessing the geometry works if you use the distance formula.
You can, yeah, but you do use the distance formula, but there is a relationship here that makes the answer very easy. So our integral would go from 0 to 2. Okay? Top function.
Kind of looks like the x plus y equals 4.
All right, it's this one, and I need to get, if we're doing x values, I need to solve that for x, so 4 minus x.
Yeah.
All right, 4 minus x. All right, minus bottom function.
There's 2 of them.
Ah, crap.
You can just add them together.
If there are two bottom functions, what do we have to do? We only get to use one top and one bottom, so here's what we have to do.
You can set them equal to each other.
Nope. We gotta cut this into two pieces, one for the one top bottom, one for the other top bottom, okay?
let's figure out what
So
they need.
this problem is not going to be from 0
To 2.
It's going to be something.
okay? All right, so nice try.
Dang, 2.
Okay. Got two bottoms, I can't do that. So let's do it the right way. We are gonna start at 0, but now we have to stop wherever this first little zone here stops.
So let's set them equal to each other, find that.
But which two? It's this one and
That one.
that one.
Yeah.
Okay, again, the y's cancel out nicely. We get 4x equals 4.
So 1.
So it's the point 1, comma
1.
1, if you plug it back in. We don't really need the comma 1, all right? So zone one is gonna go from 0 to 1, and it's gonna be him on top and, him on bottom.
Yes.
Yeah.
Then zone 2 is gonna go from 1 to 2 and have him on top and him on bottom. All right, not a big deal. So we'll do 4 minus x on top and 4 minus 3x on the bottom. Second zone will go from 1 to 2 and have 4 minus x on top and x on the bottom. Again, once I get to this part, the whole context to me is just whatever. Solve that problem, okay? So I'm going to have, I'd clean it up a little bit first. 0 to 1 of, okay, let's see, the 4's actually cancel and we get 2x. That's a positive 3 and a
Yeah,
negative
2.
1
Yeah.
makes 2x. Great antiderivative, by the way.
Pretty.
Then we're gonna go from 1 to 2 of 4 minus 2x. Right there. Okay. Problem number 1, that's an x squared, going from 0 to 1. We'll do you in a second.
4x minus x squared.
Good. 4x minus x squared from
Super pretty.
1 to 2. All right. Stick in 1, I get 1. Stick in 0, I get 0. Then we're going to add in the second part. Stick in 2, I get 8 minus 4. Stick in 1, I get 4 minus 1. Now we just have to make sure we're doing our order of operations correctly and we're good to go.
Right.
All right. Well, okay. That's 4. That's 3. 4 minus 3 is 1. 1 plus 1 is 2. So our total area there was 2.
Total. If you look at the graph, it kind of makes sense.
Kind of does, yeah. Now, try this one with geometry. Since it came up. By the way, and I caution against relying on this. If you remember on the test, that question number 1 where you were just asked to find the area under y equals x, and some of y'all were setting up calculus and when it was just a triangle, okay? It was a nice triangle, it was a right triangle, so we could do that. This one also happens to be a nice right triangle, so it's viable. What we need to know now is the base and the height. So this is what I'm gonna call base.
The height is the square root of 8.
How did you get that?
There.
Okay, good. Square root of 8 or 2 root of 2.
Get 2
Alright, so area of a triangle is 1/2 base times height. You told me the height was 2 root of 2.